Hi, this is Sage Adams again. Welcome to the second part of our Learning Microsoft Access 2013 series. In the previous lesson, we looked at customizing the interface for the application, and in this video, we're going to be looking at planning and designing your tables. We'll also look at your goal for your database briefly at the beginning. We will not be covering creating your tables, and that is because the process of creating your tables is actually really easy, and your book does a good job of explaining that. And if you're following along and not enrolled in this class, you can find lots of resources online for building your tables that are really good, and you'll see how easy it is. Microsoft.com has some good tutorials on that. So just search in Google for example, creating tables Microsoft Access 2013. So it's really quite easy. The hardest part, and what I'm going to be covering here, is doing the initial design correctly, and that's what I'm going to cover in this lesson. But first, what is your goal of your database? So before you start designing your database, before you even choose your database, you really need to come up with why are you creating your database. So I started a comic books database in the last lesson, and I don't collect comic books, so that may seem like a strange thing to create a database on. But the fact is, I actually used to collect comic books when I was a kid. So I have maybe, let's see, from the ages of I think 7 to 13, I think I collect comics. So for 6 or 7 years. And I have about 3,000 comic books, and I've been carting them around with me wherever I move for many years now. And the hope is that they'll eventually be worth something. So the reason I'm creating my database is not just busy work, not just for a grade for a class, but obviously you have to create one for this class for a grade. I understand that. But try and pick something that's interesting to you that will actually be valuable to you, and you'll enjoy it a lot more. And so creating my comic book database was really about two things. It was fun for me to create it because it brought me back to my childhood a little bit and allowed me to look at all the comics that I had enjoyed as a kid, and that was just a really fun thing to do. But second of all, when I want to sell them someday, I need to have a record of what I have. And having a digital record is a lot easier than having to go through every single comic one at a time to try and explain to a potential buyer what I have. So I wanted to put them all in a database where I can put the current, how much I bought them for and what the current value is, so I could compare, I could see how much I made, and in theory, and then later on I would be able to sell them hopefully for what they're worth. So that's the goal of my database, and I hope that you come up with a good goal for your database too. It's really important. All right, so let's look at the tables. What are tables? That's the first good question. Tables are the fundamental building blocks of everything you do in Access, or any database, really. So without tables, you wouldn't have a database. Tables are the containers that contain all of the data. So it should make sense then that planning and constructing these containers for your data is very important. Think of it like building a house. When you decide you want to build your house, you have some idea in your mind of what kinds of things you'd like to include in your house. Maybe you want a deck, maybe you want a garage, maybe a couple bathrooms, maybe you want 4 or 5 bedrooms, a living room, a kitchen, so forth. So you have this idea in your mind of what you want, but you wouldn't start building your house right away. You would design it more thoroughly than just something in your mind. That's what most people hire architects for. Luckily, you can architect your own database. So for our purposes here, you can think of these rooms in your house as tables in your database. So the house is the database, and the rooms are the tables. And you wouldn't just start building the kitchen without thinking through what it's going to look like, how it's going to be laid out, what features it's going to have, and how it will be situated to the other rooms in your house. And so it's the same with your tables. You need to think through before building them what tables you'll have, what field each table will contain, what fields each table will contain, and what the properties of those fields will be, how they'll be used individually, and how they'll all interact with each other. If you don't do this, chances are you'll end up with a poorly constructed table, or tables that don't interact well and have lots of problems. So it really makes a lot of sense to design your tables well ahead of time. So you also need to make sure that you design your tables with an eye towards what fields they're going to contain and the properties each field will have in your tables. So each table will have probably multiple fields. Some will just have one, some will have many. The fields are going to be similar, like the elements of the kitchen, such as the range, oven, microwave, dishwasher, and so forth, and must be designed properly in order to work the way you want. So in your kitchen example, you have your fields are those appliances, and in your database example, they're going to be elements of data. So you need to define which fields each table will contain and how they meet your overall objectives to what you want. You want to make sure you don't duplicate any data in any of your tables. If you find yourself duplicating data in any of your tables, you need to really sit back and objectively look at what you're doing and see, is there a better way that you can do this? So that's a big red flag if you see yourself duplicate. So if you see yourself typing in something over and over again, ask yourself, can I get away with not duplicating this? How can I not duplicate this? And usually the answer is going to be create another table for that data and then relate them together. So you wouldn't want 4 microwaves in your kitchen, for example, right? So you don't want 4 or more, unfortunately, of the same thing in your tables either. So enough of that house kitchen metaphor. Let's design our tables. So using my comic books example, which we're going to use in all of these tutorials, let's lay out the purposes of our tables. So the first table we're going to have is our main table, where we're going to store all the comics. And you're usually going to, oftentimes, I won't say usually, but oftentimes you're going to have a main table that has a lot of the data, and then you're going to have a bunch of sort of corollary tables that relate to it. And so in this table, we'll include all the following fields. We'll have an ID field, which will be our primary key, a title, an issue number, a publisher, a cover price, a condition, and a current guide value. So we need a primary key because every single comic book needs a completely unique identifier. A lot of them are going to have the same title. A lot of them are going to be similar with the condition, because there's only like 10 conditions. Some of them might have the same prices for cover price and value, for that matter. A lot of them will have the same publisher. So you need a unique value that's really going to identify each individual field. And then the other fields, title is just the title of the comic book. Issue number, comic books basically work like issue number 1 is the first issue of a comic book, and then they just go up from there. And however long that series ran, maybe it was really popular, and it had an enduring character like Spider-Man or Superman, and the issue numbers in the thousands. And maybe it was just like a short series that lasted only 4 issues, and so there's only four issues, issue 1, 2, 3, and 4, and then it stopped. Some of them went up to like issue 65, 66, and then they stopped. So it just really varies with it when it comes to comic books. Publisher, there's only so many publishers of comic books, although there's a lot more these days than there used to be. That's still going to be a pretty low number. There's only like 10 different conditions for comic books, and those are the conditions as rated by the Overstreet price guide people, and they basically determine how much you can value your comic books for. So, and there's about 10 different conditions that we'll look at. So those are the fields that we're going to have in this table. So let's take a step back for a second. Now, your natural inclination would be to have this one table, the main table, and fill out every row by typing in each value by hand for each comic book. And this is what you would probably do in an Excel spreadsheet. And that's how we're all trained to do things and think about things. And an Excel spreadsheet is actually a database also. It's a flat file database is what it's called. And you would just type you type the title, the condition, the issue number, etc. for each comic book And you just type them all out in every single row, and you'd have like 3,000 rows in your main table, and all the data would be in there. And that's how a spreadsheet's going to work. And that works fine for some presentation things and formatting and stuff. But when it comes to the power of using a database, being able to query and do other powerful things, create forms and reports and so forth, using the data, you really want to break up your tables into multiple tables. So that's why we're doing it the Access way. Also, if you have thousands of items of data like I do my comic books, it's going to take forever to put them all on a spreadsheet. So for me, it's just more efficient, besides just being better practice, to put them in multiple tables and then just relate them. So, for example, okay, so you're going to have lots of data redundancy and data errors if you just type everything into one table. So if I have 200 issues of Amazing Spider-Man, I might accidentally type one like this, and that would mess everything up, and I'd probably have a couple other spelling errors too. And why would that be? Because let's say later I wanted to do a search of all the issues I have of Amazing Spider-Man. Well, that particular issue wouldn't show up because I didn't type it correctly in Access to search for Amazing Spider-Man, which searches for the right spelling. That's not going to show up, and you're not going to be able to guess all the time all the different ways you might have misspelled something. I mean, there's a lot of common spelling mistakes, but a lot of times you might hit a completely random key like a Z or something like that and put that in something because you're typing it so fast, because maybe it's boring to put that in, do all the data input. So you type it in and you get a mess up and you don't see it. You just keep typing and keep making new rows of data, and you just miss it. And then later on, you're not even going to be able to find that particular issue. You'll think maybe you don't have it, when in fact you do. So you don't want those types of errors, and that's what we're going to try and get away from with this database design. There's other reasons not to duplicate data, but that's an important one, and so just take my word for it. Don't really try and chunk your data into multiple tables if you can. And Access is not very forgiving when it comes to spelling errors. So, it's a computer. It's not very smart. It's fast, it's powerful, but it's not smart. People can look at things and say like, oh, well, that misspelling, that's supposed to be Amazing Spider-Man. I can tell, so I'll just include that in my search. But Access doesn't know that. It can only search by the exact thing that you give it. And if you give it Amazing Spider-Man, it's not going to find those records that don't match. Just keep that in mind. So as you're doing this design, you'll think to yourself, so what can I duplicate and what can't I duplicate in this table? And that's the first question really you should ask yourself with any table. And in this case, we know we'll be duplicating the title a lot. We've already covered that. We also know that we're going to need another table for the titles. So, and then we'll relate them together so that we don't have to type them out. We'll also be duplicating the condition a lot because there are only like 10 conditions, as I talked about before. So that will become its own table. We could make a cover price another table because there's really not many different cover prices. But actually, there are quite a bunch of cover prices, probably well over 100, if not 200. So you might just find, also because it's a numeric field, it's always kind of weird to make a numeric field its own table for a bunch of reasons, but so we might just leave the cover price part of this table and not make its own table, even if it's going to have some duplicates. And in fact, I think that is what I'm going to do. And let's see what else. Right. The current guide value. So the guide, now this is going to another numeric field that's going to have so many values. It's going to have way more values than the cover price values, because really a comic book can be worth anything. It could be worth 0, 25 cents, 50 cents, all the way up to $1 million. It really depends. So there's so many values, it makes no sense to have its own table. Just make that a numeric field and be good with that. There are also, only so many publishers, so we'll make that its own table. Issue number is another numeric field that really should just be in the main table. Just because it's such a broad range, it doesn't make sense to have its own table. The ID field will be the primary key and has to be unique to this table. Alright, so we'll end up having these tables: the main table, the title table, the publisher, the condition. Those will be our four main tables. You could have had writer and artist as well, but for simplicity, I just won't go into that. So next we need to figure out what fields each table is going to contain. So we already did the main table, and that's the biggest one. The others will just have their primary field. Since they won't be duplicated, they don't need separate ID fields. So for example, condition will have new, like new, very good, good, fair, poor, very poor, and abysmal. Abysmal is not the actual guide designation, but I don't have that in front of me, so just something really bad. So that's going to be the only field in the condition table, and that will also be its primary key. And then we'll, in the next video, we'll be looking at relationships, and you'll see how you can map that relationship to the main table, so that when you fill out the main table, the column for condition, instead of typing it in, you just select from a drop-down menu which condition you want to use, and those are coming from this other table. So it makes it super easy. You don't have to worry about data entry errors or anything like that. All right, so what else? All right, so we did the main table, we did the conditions table. Oh, as long as we're building these tables, it's always a good idea also to plan for the relationships that you're going to have. So we already know the condition. I explained how the conditions, or how the relationship is going to work in the conditions column, but it's always good to write out what the relationship is going to look like, because you're going to have to design the relationship later, so you might as well do it now. So all of the relationships between all of our subsidiary tables and the main table are going to be one-to-many relationships, which means basically that one entry in the conditions table, for example, is going to have many entries in the main table. So there's going to be, for something that is like new or good, there's going to be hundreds, hopefully thousands. I hope my comics are in good condition, that are going to be matched in the main table that are like new and good. So, and it's going to be the same with the other tables. So publishers, there's only going to be like 50 publishers, and each one is going to have many entries in the main table. So those are going to be one-to-many relationships as well. Okay, so the fields that we're going to use, we should look at for a minute. The fields we're going to use for condition, title, and publisher will be the short text field type, because they're just going to be text entry, so the fields are new, like, good, whatever. Publishers are Marvel, DC, so forth, and the titles are Amazing Spider-Man, Adventures of Superman, whatever. I really liked superheroes when I was a kid, so most of mine are going to be superhero comic books. The fields for the cover price and guide value will be currency, so we can do math on them. The ID field in main will be an auto number, and the issue number will also be short text, actually, because we won't be doing any calculations on it. So that is it for tables right now. I know that's quite a long video, and I know it's a lot of information, but hopefully this gives you a lot to work with moving forward. This really is one of the most important chapters and one of the most important things moving forward with your database. So let me know if you have questions, and we're done with this week, and next week we'll look at relationships.